Welcome to your Get That Nugget for GCSE Maths. Today we'll be concentrating on giving you a framework to answer questions about equations of straight lines. This session is to complement your lessons with your teachers and is not to replace them in any way. Okay, so this is the second video of two videos on the equation of a line. Now there is a previous video which is more of an introduction of this, which goes through the general formula of an equation of a line, what it means, how to use it. So if you haven't watched that one already, I suggest going back and having a look at that one before this one. However, what I will do is we will quickly just talk about the general formula and then we'll move on to look at some examples. So if you have watched the previous video or from your previous learning, you will know that the general equation of a straight line is this: y equals mx plus c. We have got our x and our y coordinates in this formula, and then what we've also got is the m, which represents our gradient, and we have got the c that represents our y-intercept. Now, there is also a video available on gradients that may be worth going and having a look at if you're not sure how to calculate the gradient. I am going to do that in this video, but you may want to spend some time making sure you are confident on that first. So, example number 1 then, find the equation of the line below. So what we have got is this general formula y equals mx plus c, and when we are finding the equation of a line, the y and the x is always going to stay the same, and what we need to calculate is our m value, which is our gradient, and our c value, which is our y-intercept. So the first thing we're going to do is we're going to calculate our gradient, because this is the first thing that comes up in our formula. Now, the way we do this is we need to pick 2 points on our line. Now, as I have said before in our gradients video, it is a good idea to pick points like this one, which are actually on coordinates. If I was to pick this point here, I cannot get an exact value, and so it's not going to be an exact, accurate gradient. Now, you can pick any 2 points. You will always end up with the same gradient because they are in the same ratio. So I've gone for this one here. This coordinate is 1, 3. And the other one I'm going to go for is this one here. And this coordinate here is along 2 and up 5. So 2, 5. I'm going to write these here to the side so I'm not doing my working out on my graph. 1, 3 and 2, 5. And then to calculate the gradient, and I might just add this to our notes bit up here, we use this y2 minus y1 over x2 minus x1. Okay, so we're going to label our first coordinates. This is our first coordinate, this is our x value, so we're going to say this is x1 and y1. And my second coordinate, I'm going to label it x2 and y2. Now, in my previous gradients video, you will know that it doesn't matter what way around you do it, I generally just write whichever one I did first, but you will always end up with the same answer. Okay, then to calculate the gradient then, y2, which is 5, take away y1, which is 3, over x2, which is 2, take away x1, which is 1. 5 take away 3 then, that gets me 2, and 2 take away 1, that gets me 1. Now, 2 over 1 is the same as 2 divided by 1, and I can do that division. 2 divided by 1 gets me 2. Now, this then tells me my gradient is 2. So what I can do is I can then say y equals 2x plus c. So we've got our gradient value, we've substituted that into our equation. What we now need to find out is our y-intercept. Now, when we actually have a graph, this is a nice, easy thing for us to do because all we have to do is look at the graph and we just have to look at where that line touches or crosses the y-axis. So our y-axis is here and you will see that our line touches here at 1. So all I'm then going to do is I'm going to say y equals 2x, and I'm going to replace my c because I know my y-intercept now is 1, and because it's a positive number, it's going to be plus 1. And then this is my equation of this line here. Okay, let's have a look at another example. So example 2, work out the equation of the line below. Again, we need to use our general formula, y equals mx plus c. You need to know this, you need to learn this. And so we need to calculate our gradient first and foremost, that m value. So the first thing we're going to do is we're going to pick 2 coordinates. I'm going to go for this one here. This one here is minus 1, 1. And let's go for this one here. So this one here is 1 minus 3. Let's write them down here. Minus 1, 1. And then this one here, 1 minus 3. So to calculate the gradient, we're doing y2 minus y1 over x2 minus x1. So I need to label these x1, y1, x2, y2. My y2 value minus 3, take away my y1 value, which is 1, over x2, which is 1, take away x1, which is minus 1. Just needs to be super careful with our negatives here. Minus 3 minus 1, that is going to get me minus 4. And then here, because we've got our double negative, this becomes an addition. So this becomes 1 plus 1, which is 2. What I can then do is do that division. Minus 4 divided by 2 gets me minus 2. So I now know my gradient of that line is minus 2. So what I can then do is I can say y equals minus 2x plus c. I'm just replacing my m value here with my calculated gradient, which I have found to be minus 2. Now my c value is where that line, like I said, crosses my y-axis. Now because I've got a graph here, I can see it nice and easily. It crosses here at minus 1. So all I'm then going to do is say y equals minus 2x and my c value minus 1. And there we have our equation of that line. Okay, let's have a look at a couple of different examples. So these are where we don't have a graph, so we need to do something a little bit extra. Okay, so a line passes through the coordinates 0, 2 and 3, 14. Work out the equation of the line. So again, we need our general equation, y equals mx plus c. And we need to calculate our gradient first and foremost. So we're going to label these x1, y1, x2, y2. And then to calculate our gradient, we do y2 minus y1, our y2 value, 14, minus our y1 value, which is 2, over x2 minus x1, and our x2 value here is 3, minus our x1 value, which is 0. Calculate our gradient, 14 subtract 2 gets me 12, and 3 subtract 0 gets me 3. Then I can do that division, so 12 divided by 3 gets me 4. I then have a gradient of 4. So I can then say y equals 4x plus c. Now what I need to find is my y-intercept. Now on a question like this, if I look at my coordinates, I have got this coordinate here, which has got an x value of 0. So what that means is on a set of axes, this is crossing x at 0, which means my y-intercept is going to be this point here, which is 2. So I'm going to say y equals 4x plus 2. Now, this only works when we have got an x value of 0. If we have a look at this example here, we haven't got a coordinate with an x value of 0, so we're going to have to do something slightly extra again. We still start off exactly the same way. Y equals mx plus c, and we're going to label these x1, y1, x2, y2. Now to calculate our gradient, like we said, y2 minus y1 over x2 minus x1. So our y2 value we know is 7, take away our y1 value, which is 3, over x2, which is 3, take away x1, which is 1. 7 take away 3, that gets me 4, and 3 take away 1 gets me 2. Then I can do that division. 4 divided by 2 gets me 2. Now what I'm going to do is I'm going to put my gradient into my general equation like I have done for all the other ones. Y equals 2x plus c. Now this kind of question is where we have to do a little bit extra. And the reason we have to do a bit extra is to try and figure out what this is, our y-intercept. We don't have a graph where we can see it. We don't have a coordinate with an x value of 0, so we need to actually figure it out. And the way we do this is by using one of these two coordinates. It doesn't matter which one you pick, it can be either. Generally speaking, if I have negatives in there, I would go for the one without negatives, but also I'd probably go for the lowest one just to make the numbers nice and easy for me to work with. So if I use this one here, 1, 3, I know that my y coordinate of that is 3. So I'm going to substitute that in for y. So I'm going to say 3 equals. Now I know my equation of my line starts with a tooth because that's what my gradient is. And this is 2x. Now I also know from this coordinate my x value is 1. So I'm going to say 3 equals 2, and then I'm going to replace my x with the x coordinate from this point here, which is 1. And then I'm going to say plus c. Then all I need to do is simplify this. 3 equals, well, 2 lots of 1 gets me 2 plus c. Now, I think hopefully a lot of you are starting to realise what c is here. So 3 is equal to 2 plus what? Well, c must be 1, because 2 plus 1 will get me 3. And then I must remember, I've done all of that hard work, I must remember to write this out. Y equals 2x plus 1. That is my equation of the line. Okay, there are 2 examples here for you to have a go at. Both of them don't have graphs, both of them don't have coordinates with an x value of 0. So you will have to do very similar to what we did on example 4.